Hi, this is Todd Harrington. I'm the Global PetroFix Product Manager for Regenesis, and I'm going to do an overview of a poster on PetroFix, which is a micron-scale carbon remedial fluid for treating hydrocarbon plumes. As we look at the poster, I've laid out several panels, and the first panel is really just an introduction to the product. Because PetroFix actually is a remedial fluid, it's comprised of an activated carbon that's been milled down to the size of a red blood cell. It's very small, it's 1 to 2 micrometers in diameter, and it's suspended in a water dispersant mixture, which makes it very easy to handle, non-hazardous, and really easy to apply. Because it's easy to apply, it's really expanded into a lot of different application methods that you might be interested in. Some of the most common ones are ones that you might think are typical, such as grid applications where you're going after the source area of a plume. What's become increasingly more popular is the use of PetroFix to stop and intercept plumes from going off-site by implementing it as a barrier system, or even using this as an insurance policy for excavations where you're digging out dirty soils. Very easy to apply this material in the excavation. And then because it's easy to handle, we see some innovative approaches that are popping up, and I put a cartoon of an innovative approach on the lower left of this poster, which is tank basin flooding. We've actually had some customers do flooding of tank basins with the material, but it was difficult to get in after the fact, and so that's worked really well. And one of the things that we do, I do like to point out on the second panel of this poster, which is something that really just comes up. Remediation practitioners who maybe have many years of experience in the remediation industry may have already looked at other types of carbon in the market. I just wanted to distinguish PetroFix from other carbons. It's a similar carbon used within the market. It's a coconut carbon. The difference is because we've suspended in water and milled it so small, that's what makes it special in terms of injecting in the fill. So what happens is that when we did early testing, we found that when we tried to do this with, say, really fine forms of activated carbon, to say inject the product using a direct push rig, which is very common in the industry, to target plumes in situ, very difficult to get activated carbon is either granular or powdered forms in the ground, even as small as 30 micrometers. What happens is you tend to have to use high pressures. High pressures involve fracturing. Fracturing tends to be uncontrolled. And then that's what I'm trying to show in the second panel is that with seam fractures, there's room for contaminants to go by. But with PetroFix, when we put it into the ground, we inject under low pressures, we inject below the fracture pressure, and what we do is a pressurized flood of the aquifer. And when we flood the aquifer, what we're seeing is we get a nice continuous coating, I like to say from floor to ceiling and wall to wall, of your aquifer. And it's really hard for contaminants to escape. So a really superior application approach compared to other forms of carbon. And if you take a soil core out, and we recommend that people do that in all of our application instructions, and you can see visibly that continuous coating, you know that you're going to be really successful and the magic's going to happen. The best practices to really get the performance shouldn't be overlooked. In terms of, I always like to point this out. I think it's easy to take a product and just kind of run and go because there's a lot of familiarity with that in the industry. But if we compare the liquid properties of PetroFix together with some good best practices, which is what I showed here in the third panel, that can really provide some pretty special results, some really good results that you're looking for. And kind of one of the big things, the two big takeaways that we like to mention on this is that use the right tooling. We like to use long multi-port tools. These are tools that are, say, 2 or 3 feet long, that where, say, you push a rod, an injection rod in a direct push rig to depth and pull it back. If it's a 2-foot tool, you'll pull back 2 feet, and then you inject in that zone, and it really does a nice application. It acts a little bit like a packer on the subsurface and allows the material to follow the paths of least resistance. And that's really what we want to do. We're actually putting PetroFix in the paths of least resistance, which are really the flux zones. Those are where your contaminants are going. And when you coat the flux zones, you may have contamination in clays and silts. I understand that, but as those diffuse out of that PetroFix is fully coating that flux zone, and you're going to capture that. And so it works really, really well. And so using the right tooling, using some distribution testing in the field, taking some cores, observing the product, do those best practices, view our other videos we have online, or application documents, and it's all there for you, or call us for support. Kind of getting into the case studies, just trying to pick some to show you what kind of performance that we get. I have three. The first case study in the upper right is a case study that they did an online design. PetroFix has online software that's available for you to go in and experiment and get your own bids. Call us for tech support. This person did the same thing for a Virginia gas station fuel spill site in Virginia, and applied the PetroFix, roughly around 16,000 pounds, I believe, somewhere on there, and 15,200. And what they were trying to do is they're trying to go for a risk-based top closure where they had free product at the site, and they did free product removal, mobile phase recovery, until they got to 3 consecutive quarters where they were not observing El Napo. One point I'd like to make is PetroFix is not designed to go after El Napo, it's just designed to go after dissolved phase contamination, albeit that range of contamination would be low and actually quite high. And I would say we showed this in this poster because we wanted to give you, the audience, an example of a really high concentration site. The client implemented this in both a grid and barrier configuration, and then shared the results with us and saw some really great results, probably around 93–94% reduction sustained for 3 monitoring events. They were able to get no further action on that site with the risk-based closure. The second case study is one that we did in Florida. This is our oldest case study. I always like to show it. These concentrations are not as extreme around this entire site. We did have total BTEX and total petroleum hydrocarbons of over 10 milligrams per liter. We did beta test this particular site. We really went in and did distribution testing. We injected the PetroFix. We pulled some soil cores to make sure that we could actually see a continuous coating, and we knew we were doing that, and we proceeded with a full-on pilot test. The results are really shown there, that we got to non-detect within 2 months after injecting it, and it remained non-detect throughout the life and the funding of that pilot test. And that study did actually go full scale, and we are still collecting results for that. Final case study was a full-scale case study. Actually, it started also as a beta test where we had some really spectacular results. We advised our client to go through the same things that I've already talked about. Let's inject, let's do some distribution testing, take some cores. They documented that the volumes and flow rates and pressures and tool tips were all working. The pilot test, multiple orders of magnitude reduction sustained. They went to full scale. What's interesting about this full scale is the charts that we're showing here are charts from 5 different areas at the site. So it's not 5 wells from one injection area. It's actually 4 injection areas in the pilot test, and we're showing those results over a long period of time. Just seeing some really strong reductions. Those 5 sites we're calling an off-site system. So view this first chart on this lower panel case study as the sort of like barrier systems that our client put in. These barriers actually had 3 or 4 or 5 rows of them, so they look like a grid in some cases, but they're designed to truncate this very large multi-acre plume that was going off-site. And looking at naphthalene concentrations as well, those were performing tremendously well, easily getting well above 90% reductions on everything at the site. So if you need any other help, if you have any questions about application or design approaches, or even if you're playing with the online software, would like us to do a review or even help through that, happy to help you at any time for that. So I can be contacted at 303-399-1622 or by email at tharrington@regenesis.com. Thank you.